Okay, in the previous class, we have seen introduction to projections of the solids, and we've solved one problem in the AutoCAD 2. So today, we will going to solve one basic problem. If a certain pyramid or a prism is actually lying on HP or either lying on VP, we will consider that, and then we will try to get the projections. So in the first problem, and after that we will solve somewhat level 2 problem, if you consider this one as the level 1. And in the level 2 we will take a problem in which the prism or pyramid, which should be actually inclined to one of the planes, either horizontal plane or vertical plane. So before going into the topic, I just want to remind you guys about the previous session. So in the previous session, what we were actually given was a rectangular prism. It's not a pyramid. Prism means, it is having both the same type of planes at the base and the top side. So we will call that one as a prism. A rectangular prism is actually having whose lateral faces, one of the lateral faces is actually inclined at 27 degrees to the vertical plane, and is actually lying on the horizontal plane. So first I've drawn that one in the AutoCAD in a three-dimensional way, so I don't think there is much of a difficulty in understanding that one. And later that, first we have taken this, since from this top view we will be able to see on the rectangle whose lateral sides are actually at an inclination of 27 degrees. So we have projected all of these to the front view, and we got one dotted line also, because that one is a non-visible edge, since we are able to see three visible three edges. So we will represent them with some darker edges here, but since we are not able to see that non-visible edge, so we have represented that one with a dotted line. And similarly, we have completed that particular problem. I think you guys might have known what is meant by prism and a pyramid, and so I'm gonna start today's session. So in today's session, I'm going to consider this problem. So a pentagonal my internet is broken, so I don't have a choice but to record this video. I'm having these issues since long time. On HP Okay, so a pentagonal pyramid is there. So what is meant by a pyramid? Yes, so at the base there will be a plane lamina. So if it is a square pyramid, there will be a square. If it is a pentagonal pyramid, there will be a pentagon. If it is a hexagonal pyramid, there will be a hexagon. And at the top, when it comes to the top, there will be only an apex. Okay, all of these they will be entire volume will be concentrated at certain single point. That point is actually known as the apex. I'm going to try to depict this one in the three-dimensional view in the AutoCAD, and after that I'll go to the 2D view. and most of you are not even submitting the assignment. Today you have to submit 2 different assignments. Submit them by 6 p.m. today. Okay, I have to generate the report. Okay. It's a pentagonal. They have eyesight. Let us generate this one randomly, and then I will go to the problem. So I'd say something like, since it is just for sake of reference, I will say 9. Okay. I don't want to make this complicated. I will just draw the real drawing. Actually, the side is not 30 mm. Dimension is different. $86. Okay. So we have actually created a pentagonal pyramid here, but we need a horizontal plane and vertical plane. Yeah. Okay, let's use the plus one. Say 1. And similarly for this one also. 1. Let me move this one using the move tool. For the purpose of understanding, I've reduced the size of this thing. I don't want these edges to be, yeah, I just put it. I really thought so. Okay, all the edges are on this one. So let's name this one as I'm not going to rotate this one because okay, I'm going to just leave it like that. Okay, so from the front, let's see the given condition here. A pentagonal pyramid of 30 mm base edges and axis 70 mm long is lying on the HP. So let's assume that this side of this pentagonal base here, say 30 mm, and the height is 70 mm. Let's assume it. Okay. This one is the axis here. So if you want me to, I can change this to an axis line. Is it was set to by there? Okay, I'm gonna do one thing. I'm gonna change the line properties of this one. Not the width. The axis line. Okay, this one also fine. Okay, so that's the axis of the pentagon. Now we have drawn this pentagon with the same dimensions, but should be on HP such that one of its base edges is perpendicular to the VP. This base here, see here, this one is an edge. This one, this one, this one, this one. These are 5 different base edges here, and one of the bases edges should be perpendicular to this vertical plane. That is how we should need to place this one. So that is what was given to us. So what I'm going to do is I'm going to select the rotate command. I'm going to select this object, and I'm going to take this one as a base point. Right now this one is not horizontal. Yes. Since ortho mode is on, it is. Let's specify this one as a base point so that I think we will be able to play with this one. Okay, so I'm going to select this one as the base point. Why it is now this one here is they were not able to select the 3D rotate base point. Rotate this one by 18 degrees. Since the ortho mode is on, it is not listening to me. $90. Okay, right now this was set to this one still not in efficiency. Okay, so we can erase this one. Since if you guys observe, we are getting a dash dot line because we are drawing everything in this line, so that's the reason why we are getting this one. So let's move it to front a little bit. Okay, right now if you watch this one from the top view, this particular edge here is actually perpendicular to the VP, right? So this edge here is actually perpendicular to the VP. I hope it is clear to you guys. Okay, and yeah, we have moved the axis to let's draw one more line, no problem. Okay. So this is the situation that we actually require. So let us watch this one from the front. So how many edges you guys are actually able to see? 1, 2, 3. How many edges have to be there? How many edges have to be there? 5, right? But you guys are able to see only only 3. I turn on this X-ray mode here. You guys are able to see only 3, still 3. See, the other 2 edges are exactly right behind these 2 edges. So that's the reason why in the X-ray mode also we are not able to see. Okay. So this is exactly the perfect front view, and in the perfect front view also we are not able to see them, but the axis line. Okay, now what we're going to do now is I'm going to try to draw the projections of this line onto the vertical plane. Sorry, let me change the layer first. If you're getting that green tick means you're actually whatever the geometry that you want to create is being created in that. Okay, if I turn off the object snap, I think I will be able to create them. Yeah, I've turned off the object snap, so that's why you guys need to learn about this object snap. If the object snap is turned off, try to move all of these 3 until they reach this plane. I think I took them inside of this plane. Okay, that's the front view of this one. Now let me draw the axis line too. Axis line have to be represented. Okay, so we will give this one, we will add them to a separate layer, and I'm going to change the width of this. I think, yeah, let's say front view and top view. What? Send them to the front view, top view. Okay. Now let's try to change the dimensions here. I think I might have changed the dimensions of. Okay, that one is a line. I'm gonna change this one too. It should be line 2. Still it is selecting the same thing. Yeah, this one is also added. Okay, these are all added. Of course, I can use the turn off option to it. These are all visible. Let me change the line width to something like this. Still, I'm not going to see any change. I'm going to give it a different color. Say red to the front view. And say green to the front. And green to the top. So I can change the color of the lines from the layers too, but this one is fine. Okay, let me draw the top view now. Before, yeah, no need. I'm gonna just take the outline of this one. I move this one very much closer to that. It's going to snap. Just done it again. Let me add a different layer. Okay, since I need to give different colors to both of them, thank you. I'm gonna just give this one a green color. So since I think that particular layer is selected, yeah. So whatever the lines that I'm about to draw will be in green color. You can change the color of the lines. In two different ways. I've been showing only one method to you guys. This is another method. So once it came to the edges, I can use the C command, okay, in order to close the curve. So all these edges are visible to us. So let us draw okay. Can you guys see that green color top view? Since all these edges are visible to us, we have to represent them in the top view. This axis line will just look like simply just look like a point. Okay, let's draw this one in the 2D view. I think I might have zoomed it a lot. Okay. Now from the front view, it looks like this. So let's draw the top view first. Okay, I'm keeping one of the edges perpendicular to the vertical plane. So for that, dot it inside. I'm going to turn off the order mode. 180 minus 108, right? So this one is 90. 90 plus 18. 162. So 30. 162. And similarly 30. 162. So this is the point that we actually require. Let me give names to this thing. Let's start from this side. You can't use capital letters. Okay. The center point Okay, when we draw the front view, we can know. Insertion point is actually changing, so I don't want that to be happening. Okay, so let us give this one a name, epics. So let us give a point. Let's name this one as O. Let us denote this one as point O. Okay. So whatever the line that is actually passing through, which means these edges. Okay, so we have to bisect this angle. That's that. Let's create a line. $90 plus 52. Yeah, 90 plus 54. It's 54. So we don't know the dimension yet. So let's say 40 and 144. Yeah, that's fine. Perfect. Yeah, maybe other methods are also there, but yeah, this one is 18. 18 plus 44. 62. 40. 62. No, I think I might have messed it somewhere. Oh no, it's 54. It should be 54. Means it will be 72. Now 18 plus 54. 18 plus 54 plus 72. Now it is. Now let's take another one. So this particular angle here is 54. Let us just draw the horizontal line. 40 and 0. Now similarly, since we got the intersection point here, I'm going to trim the additional point. I don't want to drag this session. Okay. So from the top, now the points are getting connected. So let me just project this one. Make sure the orthogonal mode is on, because if you are doing this in AutoCAD, I think the stationary shops will be opened from today. Can you guys see here? This B and D point are exactly lying on the same point, at the same point. So that's why we are not actually able to see here. Both of them are a perfect. Actually, this is not a perfect front view. In the perfect front view, they will both seems to be coinciding, like this. I don't know how to do this. So that's why A and B are seems to be coincided. Okay, here also A and E projection are lying on the same line. So I'm going to attach this audio, this AutoCAD file too. So let us take this axis here. We have to name this one. I forgot to name this one. Let's do this. Oh, no. We have to draw a vertical line. What is the dimension of the axis? 70. Up to 70. So I'm going to connect all of this. We are able to see how many edges? 3. 1, 2, 3. These 3 are the visible edges here. Since I'm in the X-ray mode, you guys are able to see more. See this edge, and this edge. These 3 are the edges we're able to see now. Let's jump to X-ray mode. Oh wait, sorry. I think I'm here. Okay, that is fine. But whereas this line here has to be, an axis line that is not a visible edge. If it is a visible edge, we will use the darker lines. So I'm gonna write it as axis. Add this to not zero layer, axis line. Close that. Now we will going to change the layer properties of the axis layer. Dash dot in this one. Yeah. Click OK. Close it. Now this is an axis line. Now this is what we are able to see. I'm going to use the color indications and see here. This is C's projection will be here. So this is C dash. We won't be able to see D dash from the front, but both of them are at the same point. Otherwise we would have got a dotted line here. If it is a non-visible edge, we will get a dotted line. Since both of these edges seems to be coinciding, we need now to represent. So E dash position is here and the A dash position is also here. Okay, and the position of O dash will be here. Okay, so this is how it will look. Let me change the color properties. Okay, so that's the blue one, sorry, this green one and the red one. I have to give the namings to this one also because it will be easier for you guys to see that. And I forgot to mention one more edge here. Yeah, I did forgot to. But I'm gonna turn this off. No, it should be written in the zero layer. See here, this is the figure that you're actually seeing here, right? This red one and this red one are same, and this green one here, I'm going to take a closer look at this one, and this green one, both are same. Okay, I hope it is clear to you guys. I'm gonna move to the next problem. I'm gonna save them, and I'm gonna attach these files in the Google Classroom. If any one of you wish to see these things, you can see. The Pentagonal pyramid. projections of solids. And now let me save this one also in the name of Pentagonal pyramid 3D. I'm gonna add these two files in the Google Classroom if any one of you wish to see them. There is an application as well in the Google Play Store. I don't know whether there is an app for iPhone. You can actually see the DWG extension files in the mobile. If any one of you are interested, you can download these files and you can also view them in your mobile phones. Okay, smartphones actually, not every mobile. I'm going to go to the next problem. Which is ma class lo unnana ma Okay guys, let's go to the next problem. So the second problem is, this one is somewhat different from the previous one. A rectangular prism of 50 by 25 mm base and length 70 mm rests with one of its longer edges of the base on HP, and the axis is inclined at 30 degrees to the HP and parallel to VP. Draw its projections. Okay. So this problem, a rectangular prism of 50 by 25 mm base and length of 70 mm rests with one of its longer edges, which means at the base we'll be having both shorter edges and the longer edges as well. So using these longer edges, it is actually resting on the HP, and the axis is inclined at 30 degrees to the VP. Sorry, 30 degrees to the HP and parallel to the VP. And so we need to draw the projections here. Excuse me. Okay. So first I'm going to try to represent this one in the 3D view, and then after that I'll go to the 2D view. So what I'm going to do is, first thing is first, let's create two different rectangles. Let me create the box first, so that it will be very much easier for me to place it. So on one side it should be 50, on another side it should be 25, and the height should be, height that was given to us is 70, right? Yeah, 70. So this is the rectangular prism that we actually need to represent. So I'm going to select, okay, reference lines. Oh. Let's move this one apart, away from this one for our convenience. Okay, let me go to the top view and I'm going to draw two different rectangles here. Basically I can do this earlier, but whereas if I don't know the dimension of this particular rectangle, then it will be somewhat difficult for me. I need to keep the vertical plane somewhat bigger because this one is having a different dimension. So I'm going to try to rotate this one about this midpoint. Perfect. Okay, so I'm going to take the press pull. That's fine. For this one also one is fine. I'm gonna move this one to no position. I go to shaded with edges mode. Yeah. That's fine. Okay, now let me name this. Everything is turned on, but I'm still not able to, I don't know. Instead of moving that one, I think this one is very much easy. Okay, I'm gonna name this one also. Vertical plane. is snapping to itself. Okay, vertical plane and horizontal plane. Now what do we need to do is we have to see the condition that was actually given to us. So the height is 70 mm, base of 50 to 50 by 25 mm. Both are created with one of its longer edges of the base on HP. So which means, see here, I'm going to take you guys to the extreme mode. See, this base here is actually having not this one, 4 different edges. This particular edge and this particular edge, both are longer edges. These two are shorter edges. So in the problem we were mentioned that this particular prism is actually resting on HP by one of the longer edges, which means either we can choose this edge or this particular edge. Okay, and what else was given to us? Inclined at 30 degrees to the HP. So what do we need to do now is we have to rotate this one by 90 degrees. Why do we need to rotate it? Because see, I'm going to show you. Say 30. The longer edge is actually resting on HP, and can you guys actually see, we can now actually draw the front view projection and top view projection. But whereas see here, these surfaces are actually now inclined to this VP. Let me show you what am I actually talking about. If I draw a line parallel to the vertical plane now, and if I draw another line which is parallel to this particular surface, these two are having certain inclination, right? I've drawn this one, these two axes here and this vertical plane. So these two are actually having certain inclination. In the problem we were told that it is actually parallel to VP. So which means, so even though it is making an inclination of 30 degrees with the HP, it should not make any inclination with the VP. So what do we need to do is we have to rotate this one by 90 degrees initially. So I'm gonna take I'm gonna rotate this object. Yeah, 90. Okay. Now, if I try to make, keep this one like one of the longer edges is actually resting on the HP, and if I try to rotate this one in this way, then there is no problem. There won't be any kind of inclination will be made with respect to the vertical plane. So that's the reason why this is the correct position. Okay, remember that. Okay, so this is how you need to imagine. So the initial position you have to decide it properly. Okay, if you are able to decide the initial position properly, then almost 50% of the problem is over. Okay, so what I'm going to do is I'm going to select this one. I'm going to use the rotate command. Since I want to keep this particular edge, I have to select the midpoint of this edge, or any point. You can choose any point. I'll go to the front view and rotate this by an inclination of 60. Sorry, its axis actually, yeah, right. Say this is the angle. I don't know, even though I'm specifying the angle, it is not taking, so I don't want that to be happening anymore. So I'm gonna take an inclination of with respect to y, right? So it has to be, say, 120. Okay, 120 plus again 180, that's 260. Basically, I don't know whether there is a problem with this AutoCAD. I don't know, no matter how many times I reinstall this thing, this problem keep on repeating. Okay, let us assume that this particular angle here is 30 degrees. Okay, right now it is satisfying all the different conditions here. So from the given problem, a rectangle, a prism. See here, the previous one is a pyramid, right now this one is a prism. So that's why it is having the same laminas on the top side and bottom side as well. Okay, and what else was given? With one of its longer edges of the base on HP, and axis is, see here, longer edge, which means this here is a longer edge and this one here is also a longer edge. These two are longer edges. So one of the longer edges is actually resting on HP and inclined at 30 degrees, which means this particular axis here is actually inclined at 30 degrees to the horizontal plane and parallel to the vertical plane. Now this one is not making any angle here, these two are parallel, the vertical plane and this one both are parallel. So whatever the projections that we are about to get are actually the actual front view and actual top view. But before going to do this one, so I'm gonna draw the initial views here, initial front view, and after that I'm gonna draw the final front view. Since whatever the camera viewport that is there, okay, which is having certain concave shape, okay, if I remove that concave shape, you will get a perfect perfect front view. I'm gonna start this. So this one. No, just no. Okay. So I'm gonna draw the XY line here. So power loss is there in between, so that's the reason why. So I'm going to change the layer properties. In the AutoCAD, zero layer can't be deleted. I'm going to create the enum text. Okay, so from the top view, if we consider the initial position here, it would be just 25, 50, okay. So let me give the namings to this one. C and D. So this is actually the base part here, which means this particular base A, B, C, D, and similarly I have to give E, F, G, H. So if I give the same namings here, so this one is going to be E, F, G location will be here, and this is H. Now if I project this one to the top, before that I'm going to have to draw a line from this midpoint up to a dimension of 70, because axis dimension that was given to us is actually 70 mm. I'm going to add this to the axis layer. Okay, so copy this one, and this one should be resting at the base, so we'll give this one A dash, and B dash will also be here, because when you're trying to look at this one, if this is A and this is B, when you watch them from the front view, A and B seems to be, resting at the same point. So that's the reason why I have to draw them like this. So at the base there is a C dash, comma D dash. Similarly, E dash and F dash. And this one is G dash, comma H dash. Okay, so the axis or center point line can be found by at the intersection point of these two diagonals. So at this particular location, point O will be there. So if I just copy this one, O dash position will be like this. Okay, So now we need to tilt this one by 30 degrees inclination. Yeah, what was actually given to us is one of the longer edges have to be kept on the horizontal plane, and then the axis should be inclined at 30 degrees to the horizontal plane. So I'm going to take this line. I will show you the two different ways to draw this one. Of course, this is not the easiest way, and the easiest way I'm about to say had to be told. So I'm going to take a vertical line here. Oh, this one is not vertical. Okay. Let's turn off the other mode. Let's give a dimension of 20 since the base is 20, and at an inclination of 120 degrees. Okay, so the midpoint of this line should coincide with the midpoint of this one. Now this condition is actually getting satisfied. So I'm going to add this one to the axis layer. I'm going to use the dimension command, and I'm going to find the angle between these two is 30. Now the axis is actually tilted to 30 degrees, and here this line here should be having a dimension of 70 at an inclination of 30. And let's take one more line here, 70 at 30. Let's join these two. Now we have tilted this particular rectangle at an inclination of 30 degrees to the horizontal. Now what I'm going to do is I'm going to copy these two. I'm going to paste them here. If you want to give the naming like O1 and O2, you can do that one as well, but this one is fine. So let's draw the projections here. Running the orthogonal mode is actually fine because because we actually need perfect horizontal and perfect vertical lines. So wherever this A dash projection and A's projection are going to meet, I'm going to name this one as A, and this is going to be B, this is C, this is D. Okay, and similarly E dash and E are meeting here. E, F, G, H, yeah, that's it. Okay, so now I'm going to first give them a color coding, and after that you guys can find what am I actually doing here. Since there is not much of a 3D work, I'm able to complete this one in a very quick amount of time. Green is fine for the top view, and I'm going to give the red color to the front view. I hope this is all clear to you guys. If you guys still have any problem, doubts, you can just ask me. So this is going to be point A1 because A dash and this and A projection are meeting here. So here A1 and B1, and similarly here C1, and similarly here D1. Okay, so let me trim these extended portions and show you guys what have I actually done here. Okay, so let's see this one in the 3D view. Can you guys actually see this? This is the actual front view that was actually represented in red color here, right? So this is the shape that you're actually seeing here. Okay, and after that, if you go to the top view, see here, there is a one non-visible edge is there because this edge can't be seen. If I turn the shaded width edges mode on, you guys will be able to see. You can see this particular edge here. Let me show this to you. We are able to see this edge, we are able to see this edge, and we are able to see this edge, but the fourth edge is not visible to us. Okay, this particular edge here at this bottom is not visible to us. So we have to represent that one with dash dot line. So I'm going to take the layers here and go to non-visible edges. Okay, since this one is already added, okay, this one is actually dotted line. Okay, dashed line. Now let me trim the axis of this one also. Okay, I think that is fine. So this is the two-dimensional view, or this is how we represent the orthographic projections, the front view and top view of this one. Okay, this is the front view and this is the top. Basically I can actually add the text to this one also, but whereas it is taking longer than I expected, and I don't know why my AutoCAD is actually crashing. So I don't want to, you know, lag a lot, and that too so many power cuts are there. My UPS is not able to hold that for that long. So I'm gonna end this session right now. Okay, I'll see you guys in the next class, but whereas let me wrap up the session by explaining the problem one more time. So a rectangle prism is there of this much of dimensions and 70 mm, which is actually resting on the horizontal plane by one of the longer edges of the base. So here if you see, this is the base of this particular rectangle prism, and the longer edges are this one and this one. I've kept this longer edge on this horizontal plane, and I've tilted this one to an inclination of 30 degrees. And after that, so if it is so, then how does it actually looks from the front and how does it actually looks from the top? I have to get it in the two-dimensional paper. For that one I have to use the projections. So like this, I've taken the initial positions of this rectangle. The initial position is very much crucial, because that's the one which is going to you know, give you the final shapes very much easily. So be careful while drawing these initial shapes, because these initial shapes are very much important. Okay, so once I've got this one, I've tilted the axis to 30 degrees of inclination, and using the projections and the common points here, I have finished the front view and top view of this particular figure. I hope this is all clear to you guys. If you still have any doubts, you can ask me in the comment section, or as well as in the Google Classroom. Okay, and so I'm going to wrap up this session. In the next class, we're going to see some of the problems which are complicated in the projections of the solids. So I'm going to take you guys to the problems where there will be prisms and pyramids which are tilted to both of these planes, both the horizontal planes and vertical planes. It is somewhat difficult, but whereas if you understand these concepts now, whatever the concepts that I've explained to you until now, then it's all going to be very much easier for you to understand that one also. Okay, I'll see you guys in the next class.